Ever stop and think about how you can recognize a friend in a crowd, remember a silly joke from years ago, or even just solve a simple puzzle? It all feels so automatic, right? But behind the scenes, the most complex machine in the known universe is hard at work: your mind. Today, we're going to take a tour inside that machine.
For the longest time, science kind of treated the mind like this unknowable black box. Psychologists really only focused on what they could see on the outside, our behaviors. But that leaves a huge question unanswered. What's actually going on inside? What if we could peek under the hood and map out the software that runs our thoughts? That one question sparked a revolution.
And that's exactly where cognitive psychology comes in. It is the science that's dedicated to systematically studying all those internal mental processes. Think of it this way. If your brain is the hardware, the physical computer, then cognitive psychology is the science of its operating system. It's all about how we process information, how we store memories, and how we generate every single thought.
But, getting to this point wasn't easy. It wasn't just a small step. It required a massive shift in scientific thinking, a true revolution that finally put the mind back where it belongs, right at the center of psychology.
This debate goes way, way back. We're talking ancient Greece with Plato and Aristotle arguing about where knowledge even comes from. But fast forward to the early 20th century, and psychology was completely dominated by behaviorism, which basically said if we can't see it and measure it, we're not studying it. So the mind was just off limits. It really took the cognitive revolution in the middle of the century, pushed forward by new tech like computers, to finally bring the focus back inside our heads.
And this slide really nails that game-changing shift. On one side, you have behaviorism, which basically said, we can only study what people do, treating the mind like it was totally irrelevant. But then, cognitive psychology came along with this radical idea. Wait a minute, the mind isn't a black box at all. It's an information processor, and we absolutely can study how it works. And just like that, a whole new scientific frontier was opened up.
Okay, so if we're going to study the mind, where do we even begin? Well, cognitive psychologists have basically mapped out the territory, identifying several core functions that are the real building blocks of how we think.
So let's take a look at this map of the mind. Cognitive psychology breaks our mental world down into 5 huge domains. We've got perception, attention, memory, language, and problem solving. These are the big pillars that support pretty much everything we do and think.
Let's start with perception. Now, this is so much more than just what your eyes see or what your ears hear. Think of it like your brain's incredible translation service. It takes all this raw data, light waves, sound waves, pressure, and turns it into something meaningful, like the face of a person you love or the sound of your favorite song.
Next up is attention. And let's be real, in a world that is constantly screaming for our focus, attention is our superpower. It's that mental spotlight that lets you tune out all the noise and zoom in on just one thing. Whether it's this explainer right now, or trying to find one specific face in a massive crowd.
Then we've got memory, the mind's very own time machine. It's not just some dusty filing cabinet for facts. It's this incredibly complex, dynamic system for encoding our experiences, storing them away for seconds or even a lifetime, and then, hopefully, pulling them back out when we need them. It's the foundation of who we are.
And of course, there's language. This isn't just about knowing a bunch of words. It's about understanding the deep, invisible web of rules, the grammar, the meaning, the social context that lets us arrange those words into an infinite number of sentences. It's how we share our most complex ideas with each other. And finally, we put it all together with problem solving. This is where the rubber meets the road. It's how we analyze the situation, figure out a strategy, and work towards a goal. And it's the same core process whether you're using pure logic to solve a Sudoku or just using a gut feeling, a heuristic, to decide what to have for dinner.
All right, so we've looked at what the mind does, but what about how it all actually works under the hood? How does information get from the outside world all the way into our conscious thoughts? Let's take a look at the brain's operating system.
So a really foundational idea here is the information processing model. And honestly, the best way to get it is to think about how a computer works. First, information from the world gets encoded. It's translated into a language the brain can actually understand. Then it's put into storage, either for a few seconds in short-term memory or for the long haul. And finally, when you need it, you pull it back out through retrieval. It's a simple but really powerful 3-step flow.
And this funnel is the perfect way to picture that whole journey. You have all this raw sensory data just flooding in at the top.
But then it gets filtered by our attention and broken down by analysis until what comes out the other end isn't just random data anymore, it's organized knowledge and actual memories. It's a constant process of turning chaos into order.
Now, here's a really crucial idea. Our brain is actually working in two directions at once. You've got bottom-up processing, which is totally data-driven. It's like building a perception brick by brick from the raw sensory info. But at the exact same time, you're using top-down processing. This is where your existing knowledge, your biases, your expectations, all shape what you perceive. It's the reason you can read messy handwriting. Your brain expects to see certain words, so it fills in the gaps. You're not just seeing, you're interpreting.
So let's see a super quick example of this, called feature analysis. When you look at this credit card, your brain doesn't just register credit card. In a split second, it breaks it down into its most basic features: the lines, the curves of the numbers, the colors, the shapes. It then puts those features back together to recognize the whole object. And in this case, it can instantly spot that something is wrong with the number sequence on the left. It's incredible how fast this all happens.
Okay, this is all really fascinating theory, but let's ask the important question. What's the payoff? Why does any of this actually matter in the real world? Well, it turns out the impact is absolutely enormous.
For one thing, cognitive psychology doesn't live in a bubble. It's constantly in conversation with other huge fields. It works hand in hand with neuroscience to figure out how our thoughts are physically produced by the brain. It's the foundation for a lot of artificial intelligence research, and it informs developmental psychology, helping us understand how our minds grow and change from the day we're born.
And tools like these are what make all that teamwork possible. Think of it this way: an fMRI is like a GPS for thought. It tells us where in the brain things are happening. An EEG, on the other hand, is like a high-speed camera. It tells us when things are happening, down to the millisecond. When you put them together, we get this incredible, unprecedented window into the living, thinking brain.
And all this knowledge leads to some seriously powerful applications. It's used in clinical psychology to develop therapies for things like anxiety or memory loss. It helps us in education, designing teaching methods that actually work with how our brains are wired to learn. It's used to make workplaces more productive and less stressful. And it's even why your smartphone is so intuitive to use. The principles of cognition are literally all around us.
So let's end on a final big thought to chew on. Cognitive psychology started out by using the computer as a metaphor to understand the mind. But now we're flipping that around. We're using our understanding of the mind to build artificial intelligence. And that leaves us with a pretty deep question. As we get better and better at modeling our own minds, are we just holding up a more accurate mirror to ourselves? Or are we on the verge of creating something else entirely, a new kind of intelligence?